In this video, we're going to be talking about aromatic compounds. So an aromatic compound is a compound that contains benzene, and benzene has the formula C6H6. So the structure of benzene, I'm going to start by drawing the full structural diagram. It's a 6-membered carbon ring, and each carbon has 1 hydrogen. Now to fulfill the 4 bonds to each carbon, we're going to have alternating double bonds within the structure. So we can write this a little bit more cleanly as a condensed structural diagram, and then we'll do a line diagram. And then finally, we can represent this cleanly and the most common way in a line diagram. It's common to represent benzene in a couple different ways. So these double bonds, the electrons within the double bonds, are quite mobile around this ring. So we can also draw those double bonds in kind of the opposite locations. And because of this, benzene is often drawn as a hexagon with a ring inside. And so what we have here is called resonance, where double bonds are mobile, and we're going to talk about why that is and what the word aromatic actually means. So within benzene, there's a phenomenon called electron delocalization. And the reason for that is that there are both sigma bonds, so those are between carbon atoms, and then there are pi bonds, and those exist above and below carbon atoms. So above and below the plane of the molecule. If we look at the diagram on the left, we see that there are orbitals extended above and below the molecule. These orbitals are going to be involved in pi bonding. So that's the double bond that we see. And so what's going to happen within those orbitals is we're going to have electron density shared above and below that molecule, and not just where the double bond exists, but kind of in general around the entire molecule. So what you see on the right, the green circles are electron density, and so you see that there's a pretty even distribution of electron density above and below the molecule. Because of this, benzene is very stable for a structure with 3 double bonds, and it tends to behave more like a saturated structure because of this. So we're going to talk about how we name benzene. And there are 2 possible ways to name benzene, depending on if benzene is the parent or if benzene is merely a group. So in this first example, in this first example, benzene is the parent. So it is both the longest chain and the most branched chain. So I'm just going to highlight benzene. And when benzene is the parent, it's called benzene. So pretty straightforward there. On this molecule, we have 2 methyl groups. And we have an ethyl group. Ethyl. Okay, we're going to use the same numbering motif that we did for cyclic alkanes. So we don't care about the double bonds in our numbering. The name benzene takes care of that. So we just want the lowest possible sum. And so to achieve that, we're going to have carbon 1 be this methyl, and then rotate clockwise around the molecule. And that will give us the name 4-ethyl. So we still list alphabetically. 4-ethyl 1,2-dimethylbenzene. We can also look at an example where benzene is not our parent, but benzene is in fact just a branch off of the parent chain. So in this compound, the reason that benzene is not our parent is that our parent chain, here it's heptane, has another branch off of it. It's too complex to name if we try to make benzene the parent. So heptane is our parent, and we have two groups here. So we'll start with our easy group. We have our ethyl, and then our more complex group, so this benzene group here. When benzene is a group, it's called phenyl, P-H-E-N-Y-L. Okay, so when we name this, we're going to do the same kind of numbering. Benzene does not get any extra priority. So on this chain, we're going to start numbering at the left because that will give us the lowest first branch. All right, so the name of our compound is going to be alphabetical order, 4-ethyl, 3-phenyl, heptane.